Hello, good morning, friends. Myself, the whole Mistry. I am assistant professor in Mechanical Engineering Department in Mahatma Gandhi Institute of Technical Education and Research Center, which is situated in Navsari. Today, we are going a presentation on a molding sand. First, we discuss about the mold. What is mold? A mold can be described as a void or cavity created in compact sand mass with the help of pattern which mold when filled with molten metal will produce a casting. It is called a molding. Then molding. What is molding? The process of making this cavity or mold in the compact sand is called a molding. Then molding sand. What is molding sand? Molding sand are the most commonly used for making all types of mold irrespectively or whether they are used for producing casting of ferrous or non-ferrous metal. Most sand casting operations are used silica sand. Sand used for manufacturing a mold for casting process is held by mixer or water and clay. A typically mixer by volume could be a 89% of sand, 4% of water and 7% of clay. Then a characteristics of molding sand. Molding sand are refractory in nature and can withstand temperature of metal being poured without fusing. The molding sand do not chemically react with the molten metal. The sand have high degree of permeability and thus allow gases form during pouring to escape. This strength, permeability and hardness of the sand mix can be varied by the changing the structure of sand. This is the characteristics of molding sand. Then next topic is types of molding sand. There are many types of molding sand. First one is grain sand. See in a figure, it is a figure of a grain sand. Green sand, it is the sand used in the wet condition for making the mold. It is a mixture of silica sand with 15 to 25% clay and the 6 and 8% of water. As explained earlier, green sand mold are no dried and metal is poured in them into wet condition. Being damp, the sand can be easily worked with hand to give it any desired shape. This sand is used for producing a small and medium sized mold which are not very complex. This is the green sand. Next is a dry sand. See in a figure a dry sand. A dry sand is a green sand that has been dried or baked after preparing the mold. Dry sand gives a strength to be a mold so that it can be used for larger casting. This is the dry sand. Next one is a loam sand. See in a figure loam sand. Loam sand is sand containing up to 50% clay which has been worked to a consistency of binder mortar. This sand is used for loam and mold for making very heavy casting usually with the help of sweeps and skeleton pattern. This is the loam sand. Next one is the parting sand. This sand is used during making the mold to ensure that the green sand does not stick to the pattern and the cope and rag parts can be easily separated for removing the pattern without causing any damage to the mold. Parting sand consists of fire grain, clay-free dried silica sand, sea sand or burnt sand with some parting compound. The parting compound used including charcoal, ground, bone and limestone, ground nut shells, talc and calcium phosphate. This is the parting sand. Next one is the facing sand. See in a figure of facing sand. Facing sand is the sand which convert the pattern all around it. The remaining box is filled with ordinary floor sand. Facing sand form the face of the mold and comes in directly contact with the molten metal when it is poured. High strength and refractory are required for this sand. It is made of silica sand and clay without the addition of any used sand. Graphite, mollusk, etc. may be added to the facing sand, and thickness of the sand layer varies from 20 to 30 mm. This is the facing sand. Next one is baking sand. See in a figure a baking sand. Baking sand is the bulk of the sand used to bake up the facing sand and to fill up the volume of the flash. It consists mainly of old repeatedly used molding sand, which is generally black in a color due to the addition of coal, dust and burning of contact with hot metal. Because of the color baking sand, it's also sometimes called a black sand. The main purpose for the use of baking sand is to reduce the cost of molding. This is the baking sand. Next one is the system sand. This is the sand used for mechanism foundry for filling the entire flash. No separate facing sand is used of mechanism foundry. Sand cleaned and repeatedly by the addition of water binder is used to fill the flash. Because of the absence of any fresh sand, system sand must have more strength, permeability and refractoriness compared to the baking sand. Next is core sand. See in a figure core sand. Core sand is the sand used for making core. This is silica sand mixed with the coal oil. That is why it is called a oil sand. The core oil consists of lineless oil, resin, lined mineral oil in some binder. For longer core, sometimes pitch or flour, and the water may also be used to save the on cost. This is the core sand. The next topic is properties of mold sand. First one is the strength. There are three types of strength. First one is green strength, dry strength and hot strength. So let's discuss about first one is a green strength. Adequate strength and toughness are making the editing in the mold. Second one is the dry strength. Dry sand must have strength to resist erosion and also the metallistic pressure of the molten metal, or else the mold may enlarge. Third one is the hot strength. Hot molten metal static pressure of liquid metal bearing against the mold wall may cause mold enlargement of if the metal still flowing. Erosion, crack and breaking may occur unless the sand possesses adequate hot strength. This is the hot strength. Next one is the permeability. A permeability is the steam or other gases. The mold must be permeable, porous or to permit gas to escape. This is the permeability. Next one is thermal stability. Heat from the casting causes rapid expansion of the sand surface at the mold metal interface. The mold surface may crack, buckles or flakes of scrap unless the molding sand is repeatedly stable dimensionally under rapid heating. Then refractoriness. Refractoriness is the absence of melting, softening and adhesion of the sand to the casting makes for better casting surface and easier cleaning of the casting. Next is flowability. The sand should pack well flow under the load. Sand of low flowability may result in non-uniform hardness, soft mold enlargement of the casting or roughness of the casting up surface. This is flowability. Next one is collapsibility. The molding sand should also have collapsibility so that during the contraction of solidified casting it does not provide any resistance which may result in a crack in the casting. Beside this specific property, the molding material should be cheap, reusable and should have good thermal conductivity. Next is adhesiveness. The molding side should collapse during the contraction of the solidified casting. It does not provide any resistance which may result in a crack in the casting. Besides these specific properties, the molding material should be cheap, reusable and should have good thermal conductivity. Next is cohesiveness. It is the property of sand due to the which the sand grains stick together during the ramming. It is defined as the strength of the molding sand. Next is usability. Since large quantity of sand are used in the foundry, it is very important that the sand be reusable. Otherwise, apart from the cost, it will be create a disposable problem. Next, easy to preparation of control. Sand should be laid itself to easy to preparation and control by mechanical equipment. Then conductivity. Sand should be have an enough conductivity to permit a removal of the from the casting. Next is ingredient of molding sand. Molding sand are actually mixture of three or more ingredients. Green sand, clay, water, sand, also a number of other ingredient materials are added. Sand. Molding sand contain 50 to 95% of total material in the molding sand. This sand particularly may differ in the following way: average grain size distribution and grain shape, chemical composition, refractoriness, and thermal stability. Generally, the purest silica sand 99.8% silicon SiO2 is considered the most refractory and thermal stability. Excessive amount of iron oxide, alkyne oxide, and lime can cause objectable of lowering of the fusion point in some sand. The shape of the sand grains may be rounded, angular, or subangular depending on their geometric history. Next is clay. Clay is with the suitable water content. It is a principal source of the strength and plastically it of the molding sand. The percentage of 2 to 50 percentage of clay. Then the binder. Naturally molding sand. Sand plus clay is minerals. Synthetic molding sand. Essentially aggregated of extremely minerals of crystalline, usually flake safe particle that can be classified on the basis of their structure and composition into the few groups which are known as the clay mineral. Single clay mineral, mixture of clay mineral, vanguard of fire clay and special clay are used in clay. Next one is the water. Activated the clay water develop a plasticity and strength. The percentage of 1.5 to 8 percentage. Water in a molding sand is often referred to tempering water. Water is excess free water. The rigid clay coating of the sand grain may be forced together, develop a strength. Free water lubricant and makes the sand more plastic and more moldable through the strength may be lowered. Control of water in a sand clay is very important. Next is topic is special additives. Special additives for first one is the Carol is finely ground corn flour or genital and ground stretch from the corn 0.25 to 2 percentage increase green or dry strength of collapsibility. Then ground pitch by product of coke making up to the 2 percentage improve hot strength and casting finish on a ferrous casting. Next is sea coal 2 to 8 percentage. A finely ground soft coal, grey and malleability iron molding sand improve the surface finish and improve easy to of cleaning the casting. Next is gasoline about 0.4 to 0.8% a mineral improve casting finish. Then fuel oil. A little fuel oil is sometimes used as a replacement for a small percentage of water, thus lowering the total percentage of moisture present. Next one is wood floor 0.5 to 2 percentage enhance thermal stability contract of the expansion of sand by a burning of the elevated temperature. Next is silica floor. Plurgent silica a finer or 200 mesh in a coal a silica floor up to 35% increase a hot strength. Next is iron oxide 0.25 to 1% to obtain the add the hot strength. Then a pearlite. An aluminium silicate mineral 0.5 to 1% better a thermal stability of the riser insulator. Then molasses is dextrine. Can or backstrap molasses unfined to contain 60 to 70% of sugar sugar solids may be used for increased dry strength. Texture may be also used for the same purpose. This is the special additives. Next is the properties of a green sand. The property there depending on the several factor. The first one is the sand ingredient, the method of preparing the sand of for molding, the method of molding employment in using the sand, variability related to the casting such a weight, shape, kind of casting alloy and getting design. Then first one is effect of the ingredient. Each of the ingredients are have important effect of the properties principle of ingredient silica sand grain. Effect of sand grains. Casting of surface finish, mold permeability, sand strength, refractoriness, and expansion characteristic are all influenced by the sand grain portion of the mixer. Sand grain contour of the mold cavity. Fine grains, smooth wall at the metal interface. Next is sand grain and permeability. Coarse sand, greater permeability, finer sand, lower permeability. The grain size distribution has a pronounced effect of the permeability. Then sand grains and strength. Strength, surface area of the sand grains available for binding. Fine sand a percentage more surface area and can develop a high strength, but the coarse more clay is required. Wide size of distribution favor strength while narrow distribution reduce the strength. Angular sand grains more strength. Next is a sand grain and refractoriness. High refractoriness sand grains of maximum purity and size impurity which discolor silica lowers its fusion point. Finer grains appear to be more easily fused than the coarse ones. Next is sand grains and expansion. A wide size or distribution dense a packing of the grain cause a expansion problem. Fine sand also expand more. Then a effect of a clay. Water is necessary to activate the clay. The first one is clay and sand strength. For first one is for clay and sand strength. For a given clay types and content, there is an optimum water content. The effect of the clay on a dry and hot strand are quite important. To low or dry strand permit washing of the sand by the metal and dirt in the casting. Too low or too high a hot strand is also undesirable. Next is clay content and permeability. Permeability is reduced by fine material in the sand increasing a clay content. Lowest permeability, higher clay content also require more tempering water and hence more steam in form when the metal is poured. Next is clay content and bulk density. Clay contents also influence the bulk density achieved by the sand during ramming. A sand having minimum bulk density has a much wide space and will have good permeability commercial with the sand grain characteristics. Next is clay content and expansion. Clay content of the 10 to 14% of sand mixer are accompanied by the minimum conform expansion value 0.03 to 0.04 in per measured of 2500 farad. A high clay content together with the proper amount of water and ramming of the sand thus favor thermal stability. Next is clay content and other properties. High, hot and dry strand are developed by vinod and vinodate clay mixer less collapsibility. Complemented material may be added to promote collapsibility. Excess clay balls good mixing is required. Next is effect of water. Close control of the moisture content of molding sand, optimum tempering water causes the clay to develop a high dry strand. The bonding action is attracted to the absorbed water rigidity and held by the clay with the absorbed water. The clay coating on the sand grains can be wedge together if sufficient force ramming is applied. Free water unabsorbed adopted by can lubricate the coating sand grains and permit a greater bulk density to reach. This is the effect of clay. Now, this video is very important to ask in a GTU exam. Asking in a GTU exam very importance of types of molding sand and the characteristics of molding sand in a 7 marks asked in GTU exam. Thank you.